In this video, we're going to talk about distribution types. So the first two major types are skewed and symmetrical. Skewed is one with a shape that is stretched out in either direction, and symmetrical is one that has a shape that, when reflected, is roughly the same. So there are those definitions. Feel free to pause if you need time to write them down. So to compare the different types, we look at the shape, the center, and the spread of the distributions. We have three ways to measure spread. Those three ways are standard deviation, which we talked about in an earlier video, range, and interquartile range. The range is just the maximum minus the minimum. Interquartile range is the third quartile minus the first quartile. And so when we're deciding which measurements to use, median and interquartile range will be used together, and then mean and standard deviation will be used together. So we've got three examples of those distributions down below. The first one is skewed left. So you can see that the tail of the data is on the left, so that's how you remember this one is skewed left. For this one, the mean is the one that's farthest left. Then the median is the one that's in the middle. And the mode is the most to the right. So remember, that's the most common. So that's where the distribution is tallest. This next one is symmetric. And in a symmetric distribution, the mean, median, and mode are all roughly the same. Then in the last option, this one's skewed right. So this is just a reflection of skewed left. So the first one is mode, and then median, and then mean. So when we're looking at these, when it's symmetric, that's when mean, median, mode are all in the middle. So that's when we would use the mean and standard deviation together as measurements. And then if our data is skewed, that's when the median is more in the middle, and that's when we would use median and interquartile range for our measurements. So if we look at this guy down here, there's the data set, and the histogram has been created for you. So we can see that this guy kind of would follow this type of distribution. That's a lovely drawing right there. So we have to decide if this is skewed right, skewed left, or symmetric. So the tail is on the left, so this guy is skewed left. So remember, if it's skewed left, the median is the best measurement of the center, and then the best measurement of spread is the interquartile range. And then we really like to look at a normal distribution. A normal distribution is a specific type of a symmetric distribution. And approximately normal distributions can be found in many real-world examples where the data are symmetric and mostly clustered around the mean. So this guy right here is an example of a normal distribution. Let's look symmetric. Now remember, symmetric doesn't have to look like this. Symmetric just means the same on both sides. So this guy would also be symmetric. Same on both sides. Okay, so again, mean, median, mode are all in the middle. We talked about standard deviation earlier. So an example of a normal distribution would be the heights of people in a large group. So you can see that it closely follows a normal distribution. And then one that's not normally distributed is the number of children in a family. So this guy, the tail is on the right side, so we'd say this guy is skewed right. So this is an example of something that is not normally distributed. And then this last example, how would you classify the following data set? Describe the shape of the distribution and the center and spread of the data. So if we look at this guy, we can see that this is skewed left because the tail of the data is on the left. So to measure this data, we would use the median because that's the measure of center that's most in the middle, and the interquartile range. So unfortunately, this data set is not in order, so we'll need to put it in order to find the median, and from there we can find the interquartile range. Okay, so I have put the data in order. The middle number, or the median, we've got 15, so the 8th number is in the middle. So our median is 98. If we look at the first half, that's this guy. So the first quartile is 76. Look at the second half, the third quartile is 115. So if we do 115 minus 76, we get 39 for our interquartile range. So those are the measurements that are best suited for this data.